Here's another video representation of the refrigeration cycle. By the time we end this class in about 2 weeks, this has got to be something that you have solidified in your knowledge of refrigeration. You need to be able to think about this just as easy as it is to put one foot in front of the other. It's a very important bit of information that you need. We're going to start off this refrigeration cycle at the compressor. Not that there is a starting point, because this is a cycle like a wheel on the tire, but the compressor is what it gets power put to through thermostat, electrical force, energy to start the system. So we'll start here. The compressor takes low pressure, low temperature vapor and compresses it. And it compresses it. We've seen other videos and other slides about the compression process. Think about any kind of cup and putting something in there, whether it is liquid or solid or air, and pushing another cup on top of it and squeezing the product that's inside that cup down to a smaller amount of space. What you do when you do that is you cause a compression, which builds pressure and also builds heat. It builds heat by taking the molecules of that refrigerant gas. Well, let's say it's 410A, just for example. It takes those 410A molecules and condenses them to the point where they're running into each other, kind of like the freeway at rush hour. A lot of cars in one area, a lot of heat building up, a lot of things running into each other. So when it does that, it changes the low pressure, low temperature refrigerant and turns it into a high temperature, high pressure gas. As that gas leaves the compressor, it runs through something called a discharge line. This is a copper tubing. It's usually 3/8, ½ inch, just depends on the size of the system, but it's a copper line that runs between the compressor and the condenser. The condenser takes this refrigerant in a vapor, high pressure, high temperature vapor form, and it runs through this coil. It enters the top, and as it runs through this coil, a fan called a condenser fan outside blows the outside ambient air, which is cooler than the refrigerant. At this point, leaving the compressor, for example, let's say it's 150 psi. That would put us at 150 psi on the 410A, which is the purple line, would put us at about 85 degrees. But let's use that number. That's not exactly right for all circumstances, but for this demonstration it will be. So the 85 degree refrigerant runs into this coil. What we need to do in this coil is lower the temperature enough, approximately 10 degrees or so, depending on the system and the type of refrigerant, to change that vapor into a liquid, which is the solid red line here. Just like a pot boiling on the stove, if you take a lid off it, your lid's going to show steam coming out the top of it, and all of a sudden when your lid hits that cool air, that steam on that lid starts dripping off the lid. It starts condensating like a glass sits on a table. It starts condensating and water cups coming in. So we're turning the moist, warm air in a room to liquid by putting a cold glass there and changing the temperature of that air just enough that it liquefies, which is called a change of state. So for example, this 85 degree refrigerant leaves the compressor. It hits the condensing coil and the outside temperature, let's say, is 75. As the 75-degree air is blown by the fan across this coil, it changes that refrigerant going through the line as a vapor to a liquid by dropping the temperature 10 degrees. So now leaving this coil at this spot on the liquid line, it changes its name from discharge to liquid because now it's a liquid. It is 10 degrees cooler than it went in. That is called subcooling, and we'll get more into that in just a bit. But that's what the process is. You're taking this high pressure, high temperature gas, putting it, spraying it or pushing it through the condensing coil outside. The air from outside is blown across it and relieving the heat from the refrigerant, and it changes the state. It takes it from the vapor to a liquid, lowering the temperature by 10 degrees. So now the subcool liquid refrigerant runs through this liquid line. In most cases, it goes through a liquid line dryer, which takes out impurities and moisture and things like that.